All right, class. Good noon, everyone. So we have shared already a class. In the very last class, we have discussed the basic concepts of chemistry, in which we have studied very simple concepts like what actually chemistry is, why do we need to study chemistry, what are the branches of chemistry, that is physical, inorganic, and organic. And rather than that, we have studied some basic physical and chemical properties. In physical properties, we have discussed solid, liquid, and gas, whereas in chemical properties, we have taken seven different type of properties, which are very common, which are very basic, and you would keep them continue in the whole class. All right, they were length, mass, temperature, uh, rather than luminous intensity, and number of moles. So this was the basic concepts of chemistry which we have discussed already in the previous class. Now, in this class, we would move to the most important topic, which is really important for your exam point of view. Class, this particular topic, this particular chapter, some basics concepts of chemistry, chapter number 1, it would come just around 5 to 6 marks. But from 5 to 6 marks, the topic today we are going to discuss scientific notation, and then we would have significant figures. This alone would measure your 50% marks of this particular chapter. So from 5 to 6 marks, you would get 2 to 3 or 3 to 4 marks question only on from this particular today's section. Okay, so please be careful, be concentrated, and let's start. All right. So class, you know very well in chemistry we have to deal with so many uh, figures, so many numbers. Like if I'm talking about Planck's constant, if I'm talking Avogadro, you know very well that these are so much bigger number. Like if this talking about this particular number, this is of mass of 2 hydrogen atoms. And same as it is, if I'm talking about Bohr's constant, that is 0.0000016. So these two terms, these two examples make a clear concept in my mind that it would be very difficult to handle these old figures. All right, these two figures just make me clarify that if we are going to make addition, multiplication, subtraction, and any kind of operation, any kind of quantity, that would be very difficult for you as well as for everyone who are going to deal with so many numbers. Okay, so for solving this particular problem, for coming out from this dilemma, we have taken a new concept that is known as scientific notation. Just to overcome the writing, the so many zeros, so many numbers, just to overcome this particular topic, we are going to take a particular new topic that is known as scientific notation. I'm clear about that. So these two figures would be same, but only the method of representation would be slightly changed. Okay, these two figures would be exactly same, but how would we write them? How would we use them in our chemistry classes or in our chemistry life? That would be changed by the method of n multiply 10 raised to power n. Now, what n defines and what small n defines? This capital N would define the whole non-zero number. I'm again repeating, this capital N would define you the whole non-zero digit. So if I'm taking suppose 602 or we are taking 62, just to make you simplify. So N would be 62 multiply 10 raised to power. How many figures these are would take as, suppose this is 7, this would represent your small n. So small n would represent number of zero digits, and in the very same manner, capital N would represent number of non-zero digits. Okay. That's the first point. That's the first way to represent your equation. Let me have an example to make you further clarify. Let we are taking 232.508. We have to write this in the form of scientific notation. N write power n. Now, what would be the method? See, if we are going to move the decimal in the left direction, the scientific notation would be exactly the same how much places I have moved my decimal. I'm again repeating. If I have to write this in the form of scientific notation, first thing, what would I do? I would check out the position of decimal. How many positions I would move either in left direction or in right direction. And what would it happen? The particular number, the particular digits which I have to move, that would make your small. Okay, so this equation would become as 2.32508 multiply 10 raised to power 2. This is a kind of mathematics you have already studied in your lower classes, but in the terms of chemistry, we need to discuss this. Okay, quite simple. You know that already. Okay, now this is the first way, this is the first example for the equation in which we need to move our decimal in the left direction. But what would happen if we have very small figure like 0.00016? You know that very well, that if we put decimal in the right direction, or I'm saying if I'm removing the decimal from the front side, what would happen? Your scientific notation would change from positive n to negative n. From positive n to negative n. We have another example. This is your positive n, and this is your negative. Let me take an example, which is 0.0016. Now, what would happen? We have to move our decimal to the right direction. Here we were moving our decimal to the left direction. When we have moved our decimal in the left direction, we need to keep our notation in the positive form. But if we need to move our decimal in the right hand side, and this is already a mathematical operation, so I don't think so we have to focus so much on this. You know that very well. Okay, so it would become 1.6 into 10 raised to power minus 4. All right, I hope I'm clear. Sorry, 0016 minus 3, the position. Okay,
Please
so
repeat,
these are
ma'am.
the okay, I'm saying 0.0016 in this particular concept. If we need to move our decimal in the right hand side, as in terms of mathematical operations, our notation n would be negative. Like if I'm taking example of 0.0016, 1.2 times to power. Should I simplify it? This particular negative n, or you
Yes,
know
ma'am.
that very well? I should repeat. Okay. See, class, let me solve it by this method. How many points? 1, 2, 3, 4. 1. The which you have since 16 divided by 10,000. First thing. Now, second one, if I'm saying I have to put this in this particular notation, what would I do? We know very well it would be 1.6 into 10 raised to power minus 4. Am I clear about that? 16 into 10 raised to power minus 4, because these are below the numerator. These are in the negative way. That's why I'm writing 16 into 10 raised to power minus. Okay. Now, this is not a complete scientific notation. This is a kind of partial scientific notation, because in scientific notation, we have to write a decimal. So we would put. Now, am I clear?
Yes, ma'am.
Clear, ma'am. Yes,
Okay,
ma'am. Clear.
very good. Okay, okay. So this is the first point which we have studied scientific notation. And what would happen if we are going to multiply, we are going to addition, we are going to subtract these particular operations? See, these are very basic mathematical concepts. You know that very well. So just to revise, let me take another example. I'm going to rub this. For an operation that we are taking, 5.6 into 10 raised to power 3 multiply 6.9 into 10 raised to power 6. You know very well, when the base is same, the power would be automatically add when there is sign of multiplication between. You know that? So what would happen? 5.6 into 6.9 would further multiply, and 10 raised to power 3 plus 6, that is 10 raised to power 9. Am I clear, class?
Yes, ma'am.
I think there should be no problem in this particular term. Okay, same as it is, what would happen if we divide these particular terms, these two terms with scientific notation? If we have to divide this, what would happen? what would
Repeat
happen?
question, ma'am.
The question is, if I'm going to replace this multiplication sign with division, what would happen? These equations, these I would say powers, add or
Not.
they would subtract. Okay, they need to be subtracted. You know very well that when we have to put this is basic mathematical operation. Then when the base is same, the power would have a negative sign if there is division sign. And what would happen if we have multiplication sign? Then the power would
Plus.
be summed. Okay. Yes, this is the point. All right. Same as it is, what would happen if we have going to addition and subtract? It would be very same. The power would not change if we are going to addition and subtraction. Let me have an example. We are going to take 6.65 into 10 raised to power 4 plus 5.55 into 10 raised to power 4. What would happen? The power would be same 10 raised to power 4 and we would add this, just that's it. So it would be as simple, the power would be same, there would be no change on the power as there is sign of positive. Okay, and the only concept of addition of power or subtraction of power would occur if we're going to put division and multiplications. Am I clear?
Yes, ma'am.
Any kind of doubt in this particular topic?
Ma'am, if we take subtract,
The power would be same, there would be no effect. That we're going to subtract this, what would happen? 10 raised to power 4 would be same. 5 minus 5, 0, 6 minus 5, 1, 6 minus 5, 1, 1.10, 10 raised to power 4. The answer would be same.
oh,
Okay.
okay, ma'am.
Okay, Ji. So now we are going to move to the next topic, that is significant figures. Okay. See, class, from this concept, you have known that we can write big or small numbers of chemistry into a particular type of notation, which is known as n multiplied 10 power n. Okay. Now we are going to take another step in this particular way, that is known as significant figure. And for going that, let me take an example. Guys are with me in chemistry lab. We are going to pursue an experiment. We're going to perform a particular experiment. What would happen? I'm taking different type of observation from every student. So if the exact answer is 2.4, there are some human error, there are some instrumental error while performing a particular experiment. So answer would be very slightly, like if my exact answer is 2.5, someone is saying 2.4, someone is saying 2.49, someone is saying 2.51, someone is saying 2.52. Okay, so these kind of particular, we can say, error would make a bigger deflection in my exact value. Okay, so particular for this problem we need to solve, we have to add another term that is known as precise, that is known as precise. Precise means exact error, this particular error, like we are having 2.5 but one says 2.4, 2.49, 2.51, 2.52, these roles. Okay, so for these two terms and for all these different kind of numbers, different kind of figures, we would put another topic that is known as significant figure. Due to all this uncertainty, we have to put another topic, we have to put another concept that is known as significant figures. Okay, now what actually significant figure is, let me have a look. See, significant figures are the meaningful digits which just make you help for making the concept very precise. I'm again repeating, significant digit which we would start in a very few seconds, which is helpful just to make our concept precise, just to avoid this our answer we use significant figures. Now, for writing significant figures, we have to take some important rules to how to calculate significant figures. Okay. The first rule is all the non-zero digits are significant figures. What I have written, all the non-zero digits are known as significant figures. For example, 253. How many significant figures are there? Only 3. How many significant figures are there? 3. The number of significant figures would be 3 because there is non-zero. Now the second rule is, if we putting our 0 in the front of the particular non-zero digit, that would be non-significant. That means if we are taking 0.3, there would one significant, that is 0 decimal would not be count. This would be non-significant. So we don't care about that. We have to only focus on the number of significant figures. And the number of significant figures in this 0.3 would be only 1. Okay, this is our second rule. Now we are moving to third rule, which defines 0 between two non-zero digits are always significant. Like we are having 2002. So how many significant figures are there? Total 4. 2002. How many significant figures are there? 4. Because these two zeros are in between two non-zero digits. Okay, this is the third rule for writing a significant figure. And the last rule is zeros at the end or right of a number are significant if they are only and only on the right side of decimal point. That means if we are having 0.200, how many significant figures there would be according to the rule? There would be 3, because the 0 before decimal would not be count, but 0 after the decimal would be count. So this is my fourth rule. But this rule is little bit twisted, and we would check how is it twisted. See, already said the rule is only and only effective if we have decimal in our particular digit. If we have decimal, like if I are having 100, the significant figure would be only 1.
3.
No, only 1. This is the twisted rule. 100, we have only one significant figure. Okay, and if we are having 100.0, then there would be 4 significant figures. All zeros are counted because there is a decimal. Okay.
समझाओ मैम.
Please keep quiet unless you're not allowed to ask. Okay, let me repeat this particular rule again. See, all these rules we said that our non-zero digits are significant figures. First, now the second point is decimal are not counted. Second, third rule, the 0 between non-zero digit are counted. And the last rule says that if we have decimal, then we would have the number of significant figures after point. So there is no point, there would be only one significant figure, because right direction की जितनी भी हमारी zero है, they would not be counted. Okay, but if we are having 100 point only, then there would be 3 significant figures. And if we are having 100.0, there would be 4 significant figures. This is the rule. You have to revise. You have to make it clear in your mind that if we have decimal, we would consider all the zeros in the right side. Otherwise, we would not consider any zero in the right hand side. Am I clear?
If the number is 100.2.
If the number is 100.2, there will be 4 significant figures. This is the same 100.2. 1, 2, 3, 4, because there is a decimal. Okay? Anyone else? Any kind of doubt? Okay, so class, that was it. We would take some examples which we would discuss at the end of our class. I hope you are with your notebook, write some questions. The first question is 0.0025. You have to write how many significant figures are in this number. 0.0025. First question, 0.0025. Second question is 500.0. Third question is 234.000. And fourth question is, yes, that we have 8008. These are the 4 questions which we will discuss at the end of class. Meanwhile, you have to write their answers in your notebook. I hope you guys are clear with this. Okay, so that was it. Now we are moving to our next topic, which is known as laws of combination. So class, this was all about the significant figures, and your exam point of view, these kind of questions will occur in your class. Oh, sorry, in your final exam. In 2 to 3 marks, that you have to write the number of significant figures in this question. Okay.
Only this type of question will make.
Only this type of question, only 50% of first step. Am I clear with you?
Yeah.
Okay. So let's we move to our next class. So next topic, that is law of chemical combination. Very basic laws and not so significant, but we will read because this is in our syllabus. Laws of chemical combination. What does it mean? How would you study different type of chemical reactions? You know very well, we have studied decomposition reaction, we have studied combination reaction, displacement reaction. Exactly. Exactly. So why I'm preferring that particular topic? Because it's the rule of our nature that when we are going to get, they would react either in the form of heat, light, or energy, and would make a different product. Okay, so when two chemicals are getting combined, the final product would make as law of chemical combination. How is our final product formed? This is only and only dependent upon 3 to 4 laws, which are known as laws of chemical combination. I'm again repeating. When we are going to mix 2 or 3 molecules, 2 or 3 reactants to make a product, how would our product form? What would be the composition? What would be the volume? What would be the number of molecules? That all depends on 2 forces, which are known as laws of chemical combination. Okay. So first rule is law of conservation of mass. And this is quite basic rule, which defines mass can neither be created nor be destroyed. I'm again repeating, this defines mass can neither be created nor be destroyed. So the second rule is law of definite proportion. The term making it clear, definite means fixed, proportion means ratio. So it's when we combine 2 or more reactants to make a product, the combination, the reactant would always make a fixed ratio. For example, we are having copper sulfate, that we are having copper sulfate 50 ml. The presence of copper would suppose it is 16%, and sulfate ion would be that we are having 74%. This is for 50 ml. If we are taking 100 ml copper sulfate, the composition would be same, 16%, 17.4%. If we are taking 1000 ml, the composition would be same. If we are taking 1 crore milliliters, we are taking 1 crore liter, doesn't matter. The chemical of and sulfate compound. Am I clear, class? Now we are moving to our another topic that is known as law of multiple proportion. Now, what is law of multiple proportion? I'm going to rub this. Multiple proportion means when we are combining two equations, they would always make a particular ratio. So I'm saying, like we are combining hydrogen and oxygen to make water. When hydrogen and oxygen would combine to make water, the particular ratio of hydrogen and oxygen would always be same to make water, even when we are using hydrogen and oxygen in higher quantities. Let me take an example. If we are taking hydrogen, oxygen to make water, it would be 2 gram, it would be 16 gram. Water is supposed 32 gram. Yes, 16 gram. Okay. Now let me increase the quantity. What would happen? Let me take 2 gram of H2, 32 gram of oxygen, there would be 34 gram of water. So the ratio, the proportion would always be same. It's 216, 232. It's 1:8, it's 1:16. This particular ratio would be always in the multiple proportion, which is the basic concept. The rule was the law of multiple proportion. Multiple means it would always be in the multiple number. Like this is 8, 16. If we further increase, it would happen 24, 32. That means in the multiple of 8. Okay, so this is the rule of law of multiple. Right? The two laws are only left. First one is Gale-Lusak's law. And the last one is Avogadro. Transform significant because when we are going to elaborate our chemistry, these are very basic rules. These are the rules when we haven't even discussed about electrons and protons. This was if two or more gases are combined or produced in a reaction, then they would make a simple ratio by volume, provided all gases are at same. And let me particular gas in a fixed ratio of volume. Okay, how is it? And oxygen to make water. Our hydrogen is of 100 ml, oxygen is of 50 ml, and the water would always be in 100 ml. This is known as a particular volume ratio. 100 ml, 50 ml, 100 ml. So it basically defines us that the volume would always depend upon the volume of the reactant. If we are taking reactant into 150 ml, our product would be in the ratio of 150 ml. If we are taking our hydrogen into 200 ml, our product would be in the 200. So it means that only and only thing is that we are having a particular quantity, a particular volume of reactant that would make us a particular product volume. Okay, that was it. And the last one is we are having Avogadro's law, which defined us that the volume of gases must contain equal number of volumes. I'm again repeating, Avogadro's law defined us that the equal volume of gases must contain equal number of molecules. That was it. This is the old rules and laws. So class, what we have studied that when we are combining two or more reactants to make our product, these all things depend on a particular laws. But these laws are getting modified again and again. Now we would go to our theory. This is known as Dalton's atomic theory. This theory was significant, was useful in that particular time when we haven't knowledge about when we haven't any knowledge about electrons, protons, and neutrons, when we only knew about atoms and molecules. That's why these rules are studied and then a kind of rejected or a kind of ignored, because we have further new concepts are about our atoms and molecules. Okay, so the last theory is Dalton's atomic theory, which we will discuss and then we will sum up. Okay. Now, the last theory is Dalton's atomic theory. What it actually defines. Dalton was a scientist which told us that all matters are made up of atoms. Dalton told us that all matters are made up of atoms. He didn't tell us about the or about the structure of molecules, but he gave us an idea that all our metals are made up of atoms. Now, the second point he said that all the atoms of a given element have identical properties, including identical mass. So, according to him, if we are having hydrogen and oxygen in a matter of water, the hydrogen would have its own property, oxygen would have its own property, which is quite clear to you, which is very basic thing, that hydrogen and oxygen has their identical properties and do not resemble in their properties. That was the second postulate of Dalton's atomic theory. Thirdly, he said that compounds are formed when atoms of different elements combine in a fixed ratio. I'm again repeating. He's saying that compound is only formed when the atoms are combined in a fixed ratio. So he said water can only be formed if we take. Am I clear? And the last one he said, which was the first rule, that mass can neither be created nor be destroyed. He took the same concept and said, in the case of chemical reaction, there would be no destruction of any kind of atom or molecule. They are just reorganized. So he said basically, if we are having H2 plus Cl2, that would make 2HCl. There would be no destruction of hydrogen. There would be no destruction of chlorine. There is just a slightly rearranged. यानी कि जो हाइड्रोजन और क्लोरीन है वो सिर्फ और सिर्फ रीअरेंज हो रहे हैं. They're not getting destroyed according to Dalton's. Okay, so these first, second, third, and four postulates were defined by Dalton, which defined as all matters are made up of atoms. First thing. Secondly, he told that a compound can only form if these molecules or these atoms are combined in a fixed ratio. So according to him, if we and one hydrogen and oxygen has their own unique property. And the lastly, he said there is no destruction of atoms in a chemical reaction. There is only reorganization. There is only rearrangement of the number of atoms and molecules in a chemical reaction. All right, class. So that was it. That was all about Dalton's atomic theory. So tell me if there is any kind of doubt. Or we just need to sum up our class. Okay, so let me recapitulate our whole class, what we have studied within 3 to 4 minutes. Then if you have any kind of doubt or query, you may ask, and we will discuss those 3-4 questions I have written in your note. Okay, All right. So firstly, we have studied about significant figures. We have studied about scientific notation. These all two terms were only dependent upon the figures about the zero, about the non-zero digit. Scientific notation told us that we have a simple concept that is known as n multiplied 10 raised to power n, where n is our non-zero digit and 10 raised to power n is we are moving our decimal to the positive side or to the to the right hand side or to the left hand side, which would make our n to positive n. This was the first thing which we have studied. Now, after discussing the scientific notation, we have moved to our second thing, which is known as significant figures. What significant figures told us? It told us that there are some basic rules according to which we can tell what significant figure is and how many number of significant figures are actually present, which was dependent upon four rules. First rule told us, is it visible? First rule told us that all non-zero digits are significant figure. Secondly, it told us that if we are having decimal and zero before decimal, it would not be count. Thirdly, it would tell that if we are having this particular number, all zeros would be count because these zeros are in between two non-zero digits. Okay. And the lastly, he said that if we are having decimal, then all zeros beside this or all kind of number besides this would be counted as significant figure. So if we are having 235.00, there would be five significant. Okay, that was it. And the lastly, we have discussed some laws of chemical combinations, laws of definite proportion, laws of conservation of mass, Gay-Lussac's law, Avogadro's law. All these laws just told us that how a reactant is mixed up to make a product. There would be some definite proportion of either volume or number of molecules or the mass that we have already discussed. And all these laws would combined up by a scientist known as Dalton, which told us